Hello, this is Ahmed Nasif, Medical Instrumental Engineer. Credits to Dr.Dina Ahmed. We're going to go for pH meter illustration for clinical chemistry. It's too important for today, and we're going to go for the electrodes for lead to meter and electrode head and filler opening, reference electrolyte and internal buffer, reference electrode and internal reference electrode diagram, separator, and glass membranes. Let's go for this video illustration. Let's start. Many liquids are so essential in our lives. They may include water and sometimes in our lives probably beverages, maybe, and dairy products and chemicals, acids and bases, or pharmaceutical products. The quality of these liquids is determined by their chemical properties. To assess these properties, various principles of measurement are used. One of these principles is pH measurement. According to the biometric principle, the principle can be traced back to 1909, when the Danish chemist Xenon Søren introduced the so-called hydrogen ions measurement exponent, the pH plus, to describe the concentration of hydrogen ions in a solution. This was basis of the development of conventional pH scale. In 1898, the Volant formulated the announced equation for that, the first time related to the electrical voltage to ion concentration. The announced equation derived pH measurement the physical basis for the pH measurement. According to the biometric principles, however, biometric pH measurement is the measurement of potential difference using the so-called glasses electrodes or non-glasses electrodes. In the cases of glasses electrodes, the pH-sensitive element in a glasses bulb that is fused to end of the glasses tube. The electrode is filled with a natural potassium chloride solution and buffered at a pH 7 and contains a silver chloride wire that forms the electrical connection. And the reference system is located in the outer glasses tube and also consists of silver chloride wire in a potassium chloride solution. A so-called junction protects the reference system from the medium to be measured without disconnecting the electrical connection between them. The pH value is calculated from the potential difference between the reference system and the measuring system. Let's take a closer look more at the pH-sensitive glasses bulb to understand how this potential difference is formulated by. Dilated hydrochloric acid, for example, contains a large negatively chloride ions charged and small positively charged hydrogen ions. When the pH sensor is immersed into this acid, hydrogen ions is able to penetrate the boundary area of the glasses membrane, so it's so-called gel layer. The consists of large chloride ions remain in the solution. The result of charge separation in the same process occurs when the inside of sensor with the natural solution buffered at pH 7. That is the constant concentration of hydrogen ions. If the hydrogen ions concentration, hence the pH value on the inside differs from the concentration on the outside, a measurable potential difference forms. If the hydrogen ions concentration on the inside lower than the outside, as shown inside the video, we can see measured solution is acidic with pH value lower than the 7 if the hydrogen ion concentration identified on both sides. No potential difference forms, and the end of the measured solution is natural with the pH value 7. Is the measured solution is based if the hydrogen ion concentration inside the glasses bulb is higher than the measured solution, so there's going to be the pH difference. pH measurement with non-glasses sensors is based on so-called ion selective field effect transistors. Very important. Short aspect, they used a mass transistor arrangement which consists a pH sensitive layer instead of metal gate. Positive hydrogen ions forming at this layer caused the charge to be separated on the other side. As a result, the area between source and drain becomes conductive. The resulting flow of current is in a direct proportion to the pH value of the medium. However, just like a glasses sensors, that is NSAIF sensors, that is also need a stable reference or potential, the potential that forms at the NSAIF that accurately be measured against the reference system is also protected from measured solution by so-called junction. So this was a fast illustration for the pH meter. I wish that I benefit everybody. Thank you for watching, and I will come with a new videos. Mansour University College.